Alright, so today we're going to be going over a popular LeetCode problem, inverting a binary tree. It's also popular in interviews too, so it's definitely worth talking about. So like any other LeetCode problem, we're going to first start by examining the instructions real good and coming up with a game plan before we even start coding. So if we go over to this zoomed in instructions that I have for us, we can see that what inverting a binary tree essentially means is switching the values of the left child and the right child. And that's not only for this first subtree, it's for all subtrees. So look, 2 and 7 got swapped, and then, or 2 and 7 got swapped, and then over here, the children of 7 got swapped and the children 2 got swapped. Example 2 is going to be a less in-depth version of the first one. So it's basically just 2 is the root, 1 is the left child, 3 is the right child, and they get swapped. And our third example, if root is null, we're going to return null. So right away, I can tell this is a recursive problem because we're dealing with a tree and it's not a fixed size. So we know we're going to have to tackle it recursively. So the next part of the problem is being able to swap the values successfully. So right here we have 2 and 7. If we want to have them swapped, you might just think, oh, well, I'll just assign the value of left to the value of right. Sure, if you do that, you'll end up with 2 and 2. And 7 is completely gone, so you have no way of referencing that. So my solution to that would be to create a temporary variable to assign left or right to. It doesn't matter, just assign it to a temporary variable, and then you're safe to overwrite it because you have the temporary value stored away. So for example, if I store 2 away in the temporary variable, I can then assign right to left, and then I can assign the temporary back to right, and that will successfully do the swap for us, and we'll be able to save the value without overwriting it. So let's first start off by tackling our base case, example 3. So we're just going to say if root is equal to null, we will return null, and that will cover that. So the real meat of our solution is going to be in this else clause. So let's just say the root is not null. What are we going to do? First, as I said, we're going to create a variable that will hold our temporary value. So we're going to call that tree node temp, and we can assign it to root.left. And now we are safe to overwrite root.left. So we can do root.left is equal to root.right. And now we can say that root.right is equal to temp. So what essentially this does is we're first saving the value of root.left to the temporary value, and then now that we have it saved away, we can reassign left to the value of right, and because it's overwritten, it's okay now because we have it in that temporary value to reassign it to right. So what we have right here essentially covers example 2, but we still need to tackle the whole idea of making it recursive so that it can work for any size of a tree. So in order to do that, we're going to call the method that we're working with here, invert tree. We're going to call it on root.left first, and this will go down the entire left subtree for us, and it'll invert it for us and switch all of the children for us down the left subtree. And once it reaches the end, we can call it once again, but this time we will call it on root.right. So this will take care of the right subtree for us, and then we can just return root. So if we run this, we will see that it was accepted with 0 ms runtime. Let's submit that just to get a little more data on it. So it ran 0 ms faster than 100% of other Java submissions. Memory usage was 41.9 megabytes. So you definitely can do this with less memory, and I'd be curious to see how you do that, but this solution made the most sense to me, and it still performs really well, and I feel like it's the easiest way to explain it to a beginner, to someone who's just trying to do this for the first time. So thanks a lot for watching. I hope you found this solution useful, and let me know if you actually have a better solution in the comments. Thanks a lot.